Okay, so yesterday what we were doing this soft iron magnetism. In that soft iron magnetism, we had seen that soft iron magnetism is more complicated compared to hard iron magnetism because because here the induction is the induction also depends on the heading on which the vessel is sailing, and after the induction when it is caused, that will depend on the after the induction what the force which is generated in which direction that force is acting, that is also affecting the amount of deviation what the vessel will have. So the deviation is depending on two things: amount of induction on that heading, and then the direction of the force after induction. So then we have looked at that there are three types of soft iron: for an aft horizontal soft iron, a third ship horizontal soft iron, and vertical soft iron. And all three are creating three fields: for an aft horizontal field, a third ship horizontal field, and vertical field. So we have got totally 9 components. And then we had said that these 9 components are better studied with the help of soft iron rods. So then we said, so 9 soft iron rods are there. So they are basically a way of showing a way of explaining and depicting the soft iron magnetism on the ship. So these soft iron rods are not physical rods. They are just a way of expressing or way of showing the effect of soft iron magnetism on the ship. So as I said, this is a mathematical concept, but we are not going to study the mathematics part of it. We are going only to see the physical part. Okay. So before we go into the these 9 rods, we have to understand there are certain conventions about these rods before we see what are these rods. The first convention which is there is, and these conventions, okay, please write it down. Okay, so you'll just write it down the convention. Okay, this is just one or two lines. Okay, this is the only thing and the definitions which I will tell you to write. So these are not the dictations. These are important things. That is why I'm telling you to write. The first convention is that soft iron rods don't have any width. Soft iron rods don't have any width. Hello, are you writing?
Sir,
Yes.
you repeat soft iron rod don't have any
Width.
with WITH
Yeah. Width.
width. Okay.
That means soft iron rods don't have any width, which means that we will consider the induction, which means you can write, which means we will consider the induction only along the length, which means we will consider the induction only along the length. Okay. So what is the meaning of this? Is this? Let us say I show one file of the shape is like this, and I show one rod like this. Let us say I show one rod like this. So the induction in this rod, or I show one rod like this. Okay. And let us say I show another diagram and I show one rod like this. So the induction, these rods don't have any width. That means these rods have to be shown like this. Okay, rods are not like this. No. That means in this case, you can see there will be a maximum induction. So this will become blue and this becomes red. But in this case, there will be zero induction. You cannot say that this rod is having width. Okay. So इसमें से half जो है, half will become blue. So the half of this will become blue and half of them will become red. So rods don't have any width. That means the induction in them will be only along their length. Is this point understood?
Yes, sir.
Hello.
Yes, sir.
Second convention. Convention number 2. The near end of the rod, the near end of the rod is located, near end of the rod is located either just forward or just aft of the compass position. Near end of the rod is located either just forward or just aft of the compass position, comma, just on the starboard side or just on the port side of the compass position. Near end of the rod is located either forward or aft of the compass position, comma, or right on the starboard side or just on the starboard side or just on the port side of the compass position, comma, or just above or just below the compass position. Just above or just below the compass position. Hello, you have written? I repeat again. The near end of the rod is located either just forward or just aft, comma, or just on the starboard side or just on the port side, comma, or just above or just below the rod, just below or just above the compass position. So what is the meaning of this? Let us say I show one rod like this. Okay, this is one rod. So you can see in this case that this is the near end of the rod and this is the farther end of the rod, or you can say away end of the rod. So this is the one which is closer to the compass. So we call it near end of the rod. And other one we can call it farther end of the rod. So in this case, the near end of the rod is just on the starboard side, right? Hello.
Yes, sir.
Similarly, I can show one more rod. Okay, in this case, this dot is the compass position. This dot. In this case, you can see the near end of the rod is just forward of the compass position.
Yes, sir.
Or if I show the vertical rod, one of the vertical rod, so let us say this is the compass position. So the near end of the rod is just above. In this case, just above or just below. So it is what I mean to say is that the near end of the rod will be either here or here, just forward or just up. Or the near end of the rod will be just on the starboard side or just on the port side. Or the near end of the rod will be just above or just below. Okay. What I mean to say that you cannot have a rod like this. So in this case, you can see this is the near end of the rod, which is neither forward or nor on the starboard side. It is somewhere in between. So not this. Have you understood this point?
Yes, sir.
Hello.
Yes, sir.
So near end of the rod will be either just forward or just aft, just on the starboard side, just on the port side, or just above or just below. You cannot have like this. Okay. You cannot have a rod like this. So you cannot have a rod like this, which is neither forward or nor just above. So this is not. Then the third convention. The third convention is that the near end of the rod, near end of rod is taken as positive. Is just a sign convention. So near end of the rod is taken as positive if it is forward of the compass position. Near end of the rod is taken as positive if it is forward of the compass position, or starboard side of the compass position, or starboard side of the compass position, or the compass position. Positive means forward of the compass position, starboard side of the compass position, or below the compass position. And the near end of the rod obviously will be taken as negative if it is located aft, outside, or above. So the near end of the rod is taken positive if it is located forward of the compass position, starboard side of the compass position, or below the compass position. And near end of the rod is taken as negative if it is located after the compass position, or outside of the compass position, or above the compass position. Just to show you an example, let us say this is the compass position. Let us say we have one rod like this. So this is the near end of the rod. So in this case, the near end of the rod is positive, positive or negative.
Positive, sir. So positive.
Hello, it will be positive or negative.
Positive.
Okay. If I say that one rod is like this, the near end is positive or negative.
Positive. Positive, sir. Positive.
So you cannot.
If I show what?
Nothing,
Cannot
sir.
what? Let us say one rod is like this. So it is positive. Near end is positive.
Negative. Positive.
Positive.
And this is the near end, na? So near end is below, na? So it is positive. Now let us talk about the red ones. Now talk about the red ones. In this case, the near end is negative or positive. In this
Negative.
case,
Negative.
okay. In this case, near end is negative or positive. It is negative.
Negative.
In this case, the near end is negative or positive. Negative. Okay. So this is positive. This is positive. This is positive. Okay. This is negative. Negative. Is this understood?
Yes, sir.
Next thing. So near end of the rod is हमने polarity decide किया कैसे होगा. Other end of the rod. So you can say farther end, or you can say other end. Other end of the rod is taken as positive if it is located forward or starboard side or below. Below with respect to what? Below the near pole. So other end of the rod. So one is near end, one is the other end. So other end of the rod is taken as positive if it is located forward of the compass position, starboard side of the compass position, sorry, forward of the near pole, or the starboard side of the near pole, or below the near pole. Okay. Written. Okay, so this is negative, and it will be negative if it is aft of the near pole outside of the near pole or above the near. So if I say, let's say it is like this, and I show one dot like this. Okay. So now this is the other pole. This is the other pole. So in this case, is it forward of the near pole?
Yes, sir.
So this will be taken as positive. So the polarity of the other pole is with respect to its position from the near pole, while the polarity of the near pole is with respect to its position from the compass. इसकी position कैसे decide होती है कि this is with respect to compass how it is located, and the polarity of the other pole is taken with respect to its position from the near pole. If I show something like this, or let me show like this. So in this case, the other pole is positive or negative?
Negative.
Because
Positive.
and what about this? Huh? Why it is positive?
Sir, because it is forward of the near pole, na, sir.
हाँ, so forward of the near pole क्या है?
Positive.
Positive, ना? Okay. And what about this one? This one will be negative or positive?
Negative.
So you can see the location, the polarity was whether it will be positive or negative. Near pole is with respect to its position from the compass, but the polarity of the other pole or further pole is with respect to its position from the near pole. तो यहाँ पे near pole का forward है. Is this point understood?
Yes, sir.
So
Sir,
like if I just a minute, you can ask your question. Just let us say this is the compass position. So now in this case, this is positive or negative?
Positive.
Positive.
negative.
Because why it is negative?
Because
Somebody-
it is above the near pole.
So above the near pole it is?
Okay, sir, negative.
Somebody said positive. Okay. Yes, somebody was asking question. You can ask.
Sir, how will we show the port side, sir, when it is port of the near pole?
वो आएगा बाद में anyway, but since you have asked.
Okay, sir, understood.
Okay. Then the fifth point is, if both the poles of a rod are positive, then the rod is positive. If both the poles of a rod, both poles positive, is rod is. Both poles are negative, rod is. Okay. One is positive, other one is negative. Any one is positive and any one is negative. That means one is negative or one is positive. It could be farther pole is positive or near pole is negative or vice versa. Then the rod is negative. So positive is positive. Negative is again positive. and positive and negative is negative. Okay.
Yes, sir.
So you can see here, we'll show you some example. One rod is like this. So tell me it is positive or negative. So this is starboard side, so this is positive. And this is forward of the near pole, so this is also positive. That means the rod is what? Positive.
Yes, sir.
Yes, sir. Positive. Both positive.
Okay. Now if I show one rod like this is port side, so this is negative, and this one is aft of the near pole, so this is also negative. This one is
Positive.
also positive.
Rod is negative.
Okay, so this is also positive and this is also positive. Clear?
Yes, sir.
This one is positive or negative?
Positive rod.
So this is forward, so it is positive, and this is above, so negative. So positive negative means it is negative, correct?
Negative.
Hello? See, this is forward, so it is positive, and this one is above the near pole, so this is negative. So that means positive negative is negative. Similarly, if I show like this is aft of the compass position, so this is negative. This is below the near pole, so it is positive. So this one is also negative. Okay.
Yes, sir.
So this is just a sign convention. Okay, doesn't have a negative. This has been made for the, so that of course this has been made with a purpose. ऐसे कोई arbitrarily किसी ने नहीं बनाया. So there is a science behind it. Okay, so this sign convention you have understood. And the last convention is that rods are considered to be of infinite length. Rods are considered to be of infinite length, in the sense that we will consider only the near pole to be effective. In the sense that we will consider only the near pole to be effective at compass position. Rods are considered to be, or rods are taken as having the infinite length, in the sense that only the near pole of the rod will be considered effective. Meaning what? Let us say I show one rod like this. So this is a soft iron rod, and now the ship is heading in the, let us say, northerly direction. In which direction this is going? H is also going in the same direction. This is a soft iron rod. So, and it is a horizontal. This is in the horizontal plane, because this is 4.5 horizontal soft iron. So in this case, what will happen? Induction will happen, and this induction, let us say, this will become blue, and other end will become red. Because the H is entering from this side and exiting from this side, so this will become blue and this will become red. So when we say last convention, the rods are considered to be of infinite length, so it means basically that only this pole we will consider effective. This one we will take as effective at the compass position, and this pole, for the sake of having effect on the compass position, this pole we will ignore. this one will ignore. Because as you know that distance plays a very large role. It is field is inversely proportional to approximately cube of the distance. So let us say if this pole is located 5 times closer than this pole, then the effect of this pole will be 125 times the effect of this pole. So we can ignore the other pole. So it is only the near pole which is considered effective at the compass position. Okay. Any doubt as far as this convention is concerned? The first convention was rods don't have any width. That means we will consider the induction only along the length. Okay. Number 2 was which one? Yeah, location of the rod is either just forward or just aft, just on the starboard side or just on the port side or just above or just below. Then near end of the rod is taken as positive if it is located forward of the compass position, starboard side of the compass position or below the compass position. And the other, and it is considered negative if it is located aft, port or above the compass position. Other end of the rod, okay, is considered positive if it is located forward of the compass position, starboard side of the compass position and below the forward of the near pole, starboard side of the near pole or below the near pole. And the other end of the rod is taken as negative if it is aft of the near pole, port side of the near pole or above the near pole. Both poles are taken as, if both the poles of a rod are positive, then the rod is positive. If both the poles of a rod are negative, rod is again positive. If one pole of the rod is positive, other pole is negative, then the rod is taken as negative. The last convention was that rods are having a very long length or infinite length. That means that we will consider only the near pole to be effective at the compass. Okay. Any doubt in these conventions?
No, sir. No, sir.
Okay. So now if I start with these rods, okay, if I start explaining the rods, all the 9 rods, it will take 1 hour.
Sir.
Yes.
Sir, I had a doubt on yesterday's R healing error, sir.
बोलिए पूछिए.
So in the healing error, it was said that the magnitude of R depends on latitude of the in which the vessel was built, and also it healing error depends on the amount of heel that the vessel changes.
Yes.
So if in order to correct it, the healing error bucket has to be brought closer to nullify the R.
See, if you want to go into the healing error, okay, if you want to go to the healing error, okay, so there are 2 components of healing error. You have seen only, I have shown you only one component. If you talk about the healing error, one is hard iron healing error and other one is soft iron healing. So this hard iron healing error is caused by force R, and soft iron healing error is caused by some of the rods like C rod healing error, G rod healing error. Okay, so rods we have not studied. So, but there is some healing error happening due to soft iron magnetism, and there's some healing error happening due to hard iron magnetism. Understand? So force R is not the only force which is causing the healing error. It is some forces from soft iron, also magnetism, also causing the vertical force at the compass position. So when we talked about that, this is the, let us say, magnetic compass binnacle, and this force, when we say this force is acting at the compass position, so this force F is R plus the forces due to soft iron magnetism. Okay.
Yes, sir.
So, so what happens that because this is permanent force and this is something which will change with the change of heading and will change with the change of place, because the induction in this will change with the change of place. Okay, so R is constant, but this component of the force is changing. That means this force F, in this case, it is variable.
Yes, sir.
So if this force becomes variable, okay, and when yesterday when I told you the correction what was done, correction when I told you that in this case when we are putting this, let us say, geometric compass, and we had kept these magnets. Okay, yesterday I told you that these magnets we are keeping, right?
Yes, sir.
Yes, we are keeping red and copper, and this we are talking about permanent. These are the permanent magnets. So that means these vector magnets, the force what they will act at the compass position will be a permanent force.
Yes,
Because
sir.
these are permanent magnets. So it will create a permanent force at the compass position. Let us say if their location is static, we are not changing the location. Okay, we are keeping the healing error bucket in the same position. In that case, it is causing a permanent force, right?
Yes, sir.
Now come back to this again. Here, this part is static, not changing. This part is dynamic. It is changing with the change of heading. It is also changing with the change of place. It is changing with the change of place, because the amount of induction will change with the, as the value of H is changing, value of Z is changing, as the vessel is going from one place to another place. But this force, because F it is variable, has been corrected by a permanent force. So is this a proper correction? No. Because a variable force should be corrected by a variable force. But in this case, variable force we are correcting with a permanent force. That means when this variable part of the force changes, either this correcting force what we have applied, either this correcting force will be more than what is required or it will be less than what is required. Are you
Yes, sir.
getting? So because it could be more than the force which is required or less than the force which is required. So because of that, the healing error will come into picture. So let us say you have corrected the healing error in latitude of 35° north, and you have adjusted the position of the uh, healing error bucket, and your healing error became zero. So your healing error became zero. Then the vessel traveled, and vessel 2 went to latitude of 10° north. So when the vessel changed the place, this component remained permanent. This component also became permanent, remained permanent, because this is permanent force, this is permanent magnetism, this is also permanent magnetism. But this one will change when we travel from 35 to 10° north. Okay.
Yes, sir.
So now what will happen? That your healing error will remain corrected or healing error will appear again.
It will appear again.
So that is why you have to adjust.
Okay, sir. Understood.
Understand? All other character magnets, you must have seen 4.5 character magnets, approximate character magnets, Flender bar, and those two soft iron spheres which are kept on the either side of the compass position. So all these corrections which are done, they are good for all the places, and they are good for all the headings. It is only and only this healing error correction is good only for that place. And when you change the place, the healing error will appear again. When you change the hemisphere, it will become more pronounced, because when you change the hemisphere, then the top induced pole of the vertical magnets will change. Okay? Because the direction of Z will change. So healing error will again have an effect, and the healing error will also change. So the healing error will depend on the this force F will be depending on the latitude because of this variable force, and that healing error will also depend on the hemisphere. So
Yes.
earlier then all the numericals were there. But then we used to do numerical on this, and there used to be one very You can say a very famous question was there. Let us say your vessel is going from Tokyo to Perth. Okay, then in the voyage, how will you correct the, how will you adjust the helium air bucket? So then by numerical example, we had to explain it. Let us say vessel is starting from 40-degree north latitude and going to, let us say, 35-degree south latitude. So in that case, what will happen? So it used to be one full 45 minutes lecture for this. But at this moment, you can say this, yes, that with the change of place, the hearing error will change. That is why you have to continue adjusting the hearing error bucket.
Okay, sir, understood.
Okay, any other doubt? Any other doubt?
No, sir.
Okay, so then what we'll do is that rods we will continue on a Monday, because if we start now, okay, it will take 1 hour to finish.
Okay, sir.
Okay. So you can log off at 12:50. Okay.
Okay,
Okay,
sir.
sir.
Thank you.
No.